Okay, so it turns out I have not been streaming. So, whoops, I've been talking for about 10 minutes and nobody is listening because I am not actually speaking to anybody. So, that was unfortunate. So, okay, let me go over everything else I was saying. So, guys, life is hard, isn't it? Anyway, so we're going to be going over a few different things today, but I just wanted to start off with just like some more administrativa type stuff. So I've talked to a few people, and it seems like people have people generally don't have a problem coming to the stream on Sunday. So that's a good time for everybody. And during the week, it seems like people are tired because they're working and they just, um, they just don't really feel like doing a bunch of coding after work, which is totally understandable. So I think what I'm going to do is I'm going to change the schedule so it's more like Sunday at 3 p.m. and Wednesday at 8 p.m. Eastern Standard Time. The Wednesday one, I am totally open to suggestions though. If anybody would prefer a different time, I think that's fine. I can be pretty flexible. Just let me know. So because this past week I was super busy. I've been on call at work, and everything is breaking. By everything, I just mean a couple things. I don't mean that like everything is broken. Just to be clear, but like, yeah, there was a lot to do this week. So it was hard for me to plan because I was kind of I was doing a lot of extra work. So yeah, so today, I think what I'm going to do is I'm going to go over a few different things that I think would be useful to everybody, and I've been trying to figure out how to like slip them in the course. I'm probably going to go over GitHub, and I'm probably going to go over a little bit about like using the terminal. So if everybody could just let me know. Uh, let me know if you what kind of operating system you use. So I imagine everybody's using either Windows, Mac, or Linux. Um, so if everybody's using either Mac or Linux, then I can actually skip something. Otherwise, I will have to go. I'll have to do something in addition. So basically, I want everybody to be able to use like a Linux terminal. That's pretty standard in software development environments. And I'd like to show you GitHub and show you just kind of like what the utility in using some sort of version control is, because it's pretty. I'm going to say it's actually pretty standard. It's I've never worked in an environment that uses a version control system besides Git. Some people might be familiar with something like Mercurial, but like it's a little bit, I've never used it, so don't ask me any questions about it. Git's pretty standard. Um, okay, so it looks like people are using Windows, which means that I will have to. Windows does not natively have a Linux terminal, so you might have seen like something like Command Prompt, but that actually uses a different that uses kind of a different scripting language. Um, what I would like everybody to do is if you're on a Windows system, I would like you to download something called Cygwin, and essentially what it lets you do is it lets you use something like a Unix shell, uh, and it's pretty cool. And then I also think that now that I think about it, so don't necessarily do this yet because I think there actually might be a Linux terminal on Windows that you can use now, especially if you're on Windows 10. So let me see if you can do that. Okay, I don't know if this will work, but Chris Hoffman looks like a pretty trustworthy contributor to How to Geek, so I assume that we can probably trust him. So it looks like so I've used Cygwin on Windows before, and Cygwin is pretty easy, and it just lets you basically run a like a Unix like shell, like you would on Mac OS or Linux, uh, and but it looks like there actually might be just like a Bash shell that you can download on Windows 10, and that'll work too. So maybe for now, just follow the setup for Cygwin. I wouldn't do that now though, unless you want to. I'd say just do that before Wednesday, because I'm just going to be showing you a couple things um, in a shell, because I think it's actually a pretty good way to do things. So I'll save that for later. And then I just want to show you what GitHub looks like. So Git is Git is what's called a version control. Like it's a version control language, and when I've talked to other developers that I've worked with, when I've asked them like, "What do you wish you had learned in school?" the biggest thing they always say is how to use version control in Git, because schools don't generally teach it. I think I got like one quick lesson on Git one time, which is not really enough time to do it. I'm of the mind that in computer science programs, or anybody learning to be a software engineer, there should be an entire class dedicated to version control, even if it's just like a 1 credit class, like, once a week. I think it's deep enough and hard enough to understand that it warrants actually like learning it deeply. So when I got to my job, uh, my mentor told me that I was a pretty good coder, but that I suck at Git. And he wasn't wrong, because I really did suck at Git. I was constantly screwing stuff up. And it was honestly just really, and it was just so stupid, like how often I was fixing these really silly errors, where if I had just learned how to use Git properly, I wouldn't have had to do it. So I'm going to teach everybody how to use Git, and it will allow you to contribute to GitHub. So GitHub is a repository for developers. So most developers will have their own personal GitHub. I actually don't really put much in mine, just because I don't really know why. Actually, there's really no good excuse for it. And I don't even think I remember the password for it, but it doesn't matter. I don't need to show you mine. But here's the cool thing about GitHub. So you can actually just search for different open source projects and even contribute to them yourself. So that's something that I will do sometimes. And you can just search for, I'm trying to think of like something that'd be cool to search for. So like for example, like I like to make like little things that like help with, or like just like little helpers for playing video games, like little overlays and things like that. So if anybody had ever played the game Hearthstone, I really liked this one. So this was a code package called Hearthstone Deck Tracker. So Hearthstone is a deck building game, and it's similar to Magic the Gathering, which probably a lot of people in this chat will be familiar with, because I've actually played Magic with some of them. And this was just like an overlay that worked with the game. And the whole project is here. Like, this is open source, meaning you can just download it, you can use it, and you can contribute to it. So you can see that like there were contributions to this a couple days ago, and this has been up for years, like probably like 5 years. And that's what something like GitHub allows you to do. It allows you to work as a community to build things, and you can find the things that are interesting to you. They don't have to be video games, obviously. They can be like, some sort of statistics package, or they can be like, maybe you just have an idea of how to build your own scripting language, and you just want to build something that everybody can contribute to. It's pretty cool. But you can always just click in and just see like, let's see what the project looks like. So you can see that there's kind of a lot here. And I know like when I first started programming, when I saw packages that looked this complicated, just give you an idea, like all these, like these are directories up here. Like these are all directories. I was pointing to the screen, like you can tell what I'm pointing at. These are all directories, and they have like all these different files in them. And these are all C# files, which is just a different programming language. It's more similar to Java. Um, and you can look through the whole thing. And I remember when I first started programming, I would just look at these and just be like, well, how am I supposed to like build something like this? These are huge. I didn't even know quite where to start. And the cool thing about GitHub is that it gives you this space where you can actually like learn stuff. And if you look in a lot of these packages, you'll actually see like little formatting errors. Sometimes you'll see like, oh, like why did they do it like that? You can totally consolidate this decision tree or something like that. And if you do that, then you can actually start making your own contributions if you learn how to use Git and GitHub. So that's what I'm going to have you work on for homework. But I just wanted to give you an idea what it looks like. So I'm being told that the stream is low res today, and it's probably because I'm running a ton of different things. So let me go ahead and close a bunch of stuff that I don't actually need running, and I bet it's going to look a lot better afterwards. So just do me a favor and let me know if this helps the stream quality. Oh yeah, I have way too much going on. That's why. So yeah, just let me know if that improves the stream quality. Before I stream, I usually take the opportunity to close things that I don't need to be using. But today I kind of just forgot to do that. So it would make sense that there is probably some latency. Yeah, it is actually pretty. Yeah, give me 1 second. Let me see if I can reconfigure a couple things. Can anybody tell me if it's starting to look any better? Okay. Here, let me try to restart the stream. That might help. Yeah, it's still really low res. What is going on? It's usually better than this. I feel like something's eating up bandwidth, and I just need to figure out what it is. Sorry about that. I will try to debug this. Hmm. Yeah, this could definitely just be like an issue with too many people are using the interwebs today. How dare they? I also probably want to start playing around with just like different stream settings and video encoders and such, because I usually don't even bother doing that. You could also try putting this on auto. Yeah, it's pretty. Mm. Yeah, I'm using OBS. If you have any if you have any insight on what I could change in OBS to maybe make this a little bit better, you can. I'm definitely open to suggestions. Yeah, that's pretty. It's pretty bad stream quality. Um, One sec. Let me just try some things and see if I can get it in a better state. Sorry about that. Okay. So if I can't get the stream video, like the video stream, to be of higher quality, I do have another idea of something that we can do. Um, but yeah, let me try lowering the FPS. Let me see if that does anything. Oh, okay, I actually have something I can do. Let me. All right, give me a couple minutes, and I'll just try to see if I can resolve this. And if not, I do have an alternative that we can use. Oh wait, does it actually look better now? Is that, how's it looking now? Is it a bit more readable? Okay, I'll take that as an indication that this is fine now. Um, I will take Josh's. Um, okay, so anyway, so yeah, I was just going over. Okay, yeah, then I'll just work with this then. But yeah, so like when I first started coding, it was like it always seemed like really daunting just to like go through an entire package and try to understand what's going on. But you actually like learn a lot by looking at other people's code, and the more the only way you get better at it is by doing it, which seems like kind of like a weird, cop out answer where it's like, yeah, just practice and like you'll get better at it. But it's kind of true. Like you don't really get better at programming if you don't do it. And the more you do it, you'll just start picking things up, and you'll really never feel like you actually understand anything when you're coding. It's always just like it's just it's just challenging, and like I'm constantly challenged, and it really never feels like I know quite what I'm doing. But you'll find that pretty much every developer feels like that. So something anyway, so that's GitHub. So if you're having problems with Sigwin, um, you don't necessarily have to use Sigwin. It's just something that I've personally used before. You also might want to try this. I think I did this once on my PC. Um, Basically, you just need to get a shell of some sort on uh, your your Windows environment, and either of these like should theoretically work. Um, and it'll allow us to start using the command line. And I think you'll find that using the command line is pretty awesome and uh, makes streaming, or I'm sorry, not streaming. My mind is a little split. It makes coding a lot easier. So something that I thought might be interesting to do is to give me one sec. So I thought what I might do is just make a new project, and I thought we might actually just go through building a a bit more of a um, like a bit more of a robust rock paper scissors program. So that's what everybody did for homework, and most of the homework assignments were pretty good. I had some comments for a few, like for most people, there was like something I could comment on, and it might have just been like it might have been related to functionality, and it also might have just been related to um, like just like formatting and such. So I thought what would be interesting would be to actually just build a full program today. And you can follow along with me. If you're having trouble reading it, just let me know, and I will use another interface of some sort. So what I'm going to do is I'm going to just go on PyCharm, and I am going to make a new project. So I thought it'd be useful just to go through that. So I will say I will call this package coding lessons. So that's where I'll put anything that I'm just kind of coding live. And I can also put the source code that I build today on the classrooms page. And we can kind of just talk about the development, like how I would go through a development process. Maybe not in the strictest, like most rigid way, but just enough so that you can kind of uh, follow along, get an idea of like how I would go about building software. So I have this folder called Coding Lessons, and then I have my Python 3.7 base interpreter. You can also use 3.8. Most people will probably have 3.8 right now. So you just do create. And we will have our new software package that we can use and build things in. Excellent. So I am going to right-click Coding Lessons up here, go to New, Python file, and I'll call this Rock, Paper, Scissors. So we're just going to start from scratch, and we're just going to build a full, just a full program, and I'll kind of give you an idea of like what I'm going for here in 1 second. So I always just start off the same way. I make a main method. Maybe just print hello there. And then if namespace name is equal to main, run the main method. I'll just put today's date here, 3/5/2020. Created on that, and then created by this. Just make sure everything works. Yep. Okay. So this is generally how I'll start when I'm coding something. Or like in Python, I'll just start with something like this. I'm not going to worry about having multiple files. We'll try to do this all in one file. And the idea here is that we're going to build a fully functional rock, paper, scissors game, but it's not just going to be playing one round. It's going to be playing multiple rounds. So the idea is that we're going to build an environment where we ask the user, how many rounds would you like to play? And then we play that many rounds against the computer, and we will determine who wins just by looking at who has more wins after a certain number of rounds. And we'll kind of run into, I'm sure we're going to run into like some interesting scenarios where we have to make some choices, some design choices. But we're just going to, first we're just going to try to outline the program and what we want it to do. And then we're going to try to actually build it. So I'm going to put, I'll use this. I'll show you in 1 second. So I'm going to use something I used to use when I was teaching called CodeShare. And just to let you know, so like this is a link to the CodeShare. Now, just a warning, you can actually like edit whatever is in here. So please don't do that. But if you go here, then you'll kind of just be able to maybe just like read along. But I'm going to do my outlining in here. So maybe just, yeah, that's fine. Okay. Outline for RPS. So the first thing we're going to do is we just want to play as many rounds as the user says they want to play. So first we're going to ask the user how many rounds, I might as well just, how many rounds would you like to play? And you play that many rounds of RPS. And then at the end, you want to determine the winner of the match. And then maybe at the end, we'll ask, allow the user to play again. So right now I'm just making an outline. So just kind of like trying to follow along and say like, this is the overall internal logic of the program and like what we're going to do. So when we play rounds of RPS, we have to do things like player inputs their choice for the round. Computer makes their choice for the round. And then determine the results of that round. So yeah, like we can just start by building each of these separately. And I'm probably going to functionalize a lot of these so that they're going to look a little bit different. So the first thing we're going to do is just determine how many rounds we're going to play. To do that, we're just going to use an input function. So we're going to say, rounds to play is input how many rounds, let me zoom in a little bit. I think you can zoom in. Maybe not. Yep, maybe not. How many rounds would you like to play? So we have this variable rounds to play here, but if you remember, this is always going to be interpreted as a string. So when you use the input function by itself, that's always a string. So we want to make that into an integer number. And let's just make sure that we're doing it right. So when we run this, the command prompt asks, how many rounds would you like to play? We'll say 10, and then rounds to play 10 gets printed to the console. So that looks fine for now. And now we're going to have to play that many rounds of RPS. So if we want to play that number of rounds, we can actually just set up a for loop. So I'll just do it like this. I'll say for current round in range, and we'll start at 1, and we'll end at rounds to play. So if you notice, I'm doing rounds to play plus 1 here because the second end of this range is non-inclusive. It is exclusive. So we want to have round 1, round 2, round 3, round 4, round 5. If we have 5 rounds, we want 1, 2, 3, 4, 5. So this will give us the ability to have each of those rounds. So if we say how many rounds would you like to play, it's just going to print 1, 2, 3, 4, 5. So we're basically running through a loop from 1, 2, 3, 4, and 5. And that's just for all of the rounds that we're going to be playing for rock, paper, scissors. So player inputs their choice for the round. We can just say player choice is input. Please enter your choice, rock, paper, or scissors. And if you remember, it's generally better to just do something like this, where you strip the characters at the end. So like you just want to remove all the white space from the end of their input, and then just convert it all to lowercase. It's just going to make it a lot easier to work with. And then computer choice is just going to be a random choice of rock, paper, or scissors. So this is actually a good time to use a constant. So we talked about constants in the last lesson. So I'm going to make a tuple up here of possible choices. So the possible choices are rock, paper, and scissors. So I'm putting this right at the top of the program, and it's basically just going to be all of these are the possible choices that we can have. And I'm actually going to surround this with parentheses because we want this to be a tuple. So we have this constant possible choices up here, and that's going to be useful a lot. So we want the computer to just choose one of these randomly. So to do that, I think what I'm going to do is I'll just say possible choices, and then in brackets here, so we can make that choice, we'll just say random.randint 0 to 2. A good question. So a tuple is a tuple is like an array, but it is immutable, meaning that we cannot make any changes to it. So with a list, we can always just change some of the contents, or we can just say like, okay, we're gonna, change rock to Spock or something. With a tuple, once a tuple is declared, you can't actually modify the tuple anymore. You want to have immutable data structures if you have like a pretty complicated program that a lot of people are working on, and you don't want people to be able to modify that, because modifying it would affect something else like in the whole coding system. So tuples are actually a good option here because we know that we never actually want these values to change. We just want them to be rock, paper, and scissors. But beyond that, you access everything the same way you would in an array or a list. So the way I made the computer's choice is I said possible choices, and I have these square brackets here so we can make a choice of like what index we want to access. And I'm just going to run random.randint 0 to 2, which is just going to, if you remember random.randint, just gives you one of the integers 0, 1, or 2 randomly. And then, so they have a uniform distribution, so we're just as likely to get 0, 1, or 2. And then we're going to choose that index of possible choices. So let's see if that works. So we'll just print out the player choice, and we'll print out the computer choice and just make sure that it works as we expect. So we want to play 3 rounds. Let's say we choose rock, and yep, looks good. Yep, awesome. So so now we have the player is able to choose what they want to use that round, and then we have the computer choosing something else as well. So it's looking good so far. So we have the ability to ask the user how many rounds they'd like to play, and then we're looping through each round, and then in each round we're going to get the player's choice and the computer's choice. So right now it looks like we don't really have any way to keep track of who wins and who loses. So what we're gonna do here is I'm gonna make some variables up here. So I'm gonna say player wins here, and we're just gonna start it at 0, and we're gonna say computer wins here, and we're gonna start that at 0. And basically every time we play a round, we're gonna be incrementing player wins or computer wins, or if it's a tie, we're not gonna increment either of them. So we'll just keep track of those up there. So I'll remove the outline here, since I think it just makes it a bit more readable. So now we actually have to determine the results for the round. So we have to determine whether it's a tie, whether the player wins, or whether the computer wins. So for that, let's just build something. So I'm probably going to consolidate this a little bit, but I think one way that makes sense would just be to say something like, if player choice is equal to computer choice, meaning everybody picks the same thing, you can just say print you tied. And that's it. So that determines whether you tied. And let's determine if the player wins or the computer wins. So we'll say if player choice is equal to rock, then, so we actually don't have to do all 3 choices. We don't have to say if computer choice is equal to rock, because that condition is actually satisfied up here, and we don't actually need to go through with it. I'm actually going to make this an else if. So if we check and we see if the player choice is the same as the computer choice, we'll just say you tied and that's it. Otherwise, we'll go to this next condition. So we have player choice is equal to rock, and we can say so we need to check basically if the computer said scissors or paper. So if computer choice is equal to paper, then we'll say, paper covers rock, so rock is going to lose, so we're going to print you lose, sad face. And then we're going to go ahead and increment computer wins by 1, because the computer just won. Like that. And then elif computer choice is equal to scissors. Then we're going to print you win, because rock destroys scissors, just as we know in real life. And then we're going to increment player wins by 1. So now let's go through the next choices, and they're all going to look pretty similar to this. So elif player choice is equal to scissor or paper. And I'm going to go ahead and cheat and just copy paste here, so you don't see me typing the same things over and over again. So we're going to say if computer choice is rock, or if computer choice is actually it'd make more sense to do it like this, so we have to type less. So if the player choice is paper and the computer chooses scissors, the computer will win. So we will print you lose, computer wins increments by 1. And then elif computer choice is equal to rock, we're going to print you win, and player wins is going to increment by 1. And then last choice, we're going to have player choice is equal to scissors. So this is if the player chooses scissors. We're going to go ahead and copy this because I'm lazy. And we're going to, so scissors loses to rock. So if the computer choice is rock, you're going to lose. And if the computer choice is paper, then you're going to win. All right, so we kind of have our decision tree here. So maybe let's just play 1 round and make sure that that works as expected. So let's say we'll play 1 round, and please enter your choice. We're going to choose rock, and it just says you win. So already I see kind of like an issue with just kind of like the user experience here. I think it would just be better if after the player makes their choice and the computer makes their choice, we should say, you know, the player chose this and the computer chose this. So let's go ahead and put that here. We're going to say you chose, and then we can say player choice. So to give you an idea of what I'm doing here, I'm using print, and I'm printing a string you chose. And then I'm using this comma as a string concatenator. So we put 2 strings together because player choice in and of itself is a string. And then we can say computer chose, and then computer choice. So let's go ahead and play around there. Let's see how that looks. 1 round, and we'll choose rock. You chose rock. Computer chose scissors. You win. Hooray. We're so good at this. And I think the comma actually puts in a space by itself, so we'll go ahead and just take away that space. So we'll play 1 round. We'll choose paper this time because we are fancy. You chose paper, computer chose paper, you tied. All right, so that's actually looking pretty good. It looks like we can play around, and it functions as we think it should. So let's see what we have so far. We have the ability for the user to say, I would like to play this many rounds. And then we have these variables, player wins and computer wins. And we start them off at 0. And then we loop through each of the rounds. And we allow the player to make their choice. They input rock, paper, or scissors. We take the string that they send, and we remove all the white space from the end. And then we convert it to lowercase so that it's going to be easier to work with. The computer is going to choose a random value that's in this tuple up here, possible choices. I'll even make a note here. Tuple containing all valid RPS choices. We use random.randint to choose a random integer, either 0, 1, or 2, to grab the index. And so computer is going to choose with equal probability rock, paper, or scissors. We print out what each agent in the program chooses, and then we determine the results in each round. So first, we check to see if they tied. We check to see if whatever the computer chooses and what the player chooses are the same. And in that case, we're just going to say that they tied. If player chooses rock, we check to see if they win or lose. Paper, scissors, same way. And then each time we're going to either increment computer wins by 1 or we're going to increment player wins by 1. And then it looks like now we would need to determine the winner of the match. And we want to allow the user to play again. But before we do anything else, I'm already noticing that we're kind of putting all our code in this main function right here. And generally, you want to not do that as much as you can because it's just going to get kind of messy and a little less readable. So it's better to just consolidate code if you can. So I'm already seeing an easy consolidation, so we just wouldn't have to do as much. I'm going to write a function that basically does what this whole snippet, this code block, is doing. I'm gonna write a function called get player and computer choice. and it's going to return a value for player choice and computer choice. So what we're going to do is we're going to take this code, I'm going to copy it into here, and then I'm going to return player choice, comma, computer choice. And then down here, what we're going to do is we're going to say player choice, comma, computer choice is going to be whatever get player and computer choice is up here. So all we did was we just moved some code into a function, and I just did that for some readability because I generally just want to make, oh, and we can get rid of that too. In your main method should just be like, this is exactly what the program does, and you should be able to read a main method pretty easily and just say like, this is the logical flow of the program. And if you try to like throw in a bunch of stuff in the main function, it's just going to be so much less readable. And you'll kind of find that the more you program, readability is really, really important. So I try to make my code as readable as possible when I can. All right, so we have a pretty decent setup so far. So something I'm going to do is I'm going to copy everything here and throw it into this code share. So if you go to codeshare.io/rpsalulis, you will see just like kind of what we're working on so far. Yasas, Diganis. So we have somebody else joining the stream. So let's go ahead and determine the winner of the match. So to determine the winner of the match, we need to just compare player wins and computer wins. So we have a few different possibilities here. We have, if the number of player wins and computer wins is the same, then we are going to say that they tied. If player wins is greater than computer wins, the player wins. And if the computer won more, then the computer wins. So let's just go ahead and just put in a simple if tree to just determine who the winner is and present that. So if player wins is equal to computer wins, we'll just print you tied. Else if player wins is greater than computer wins, we're going to print you win. And then else if player wins is less than computer wins, print you lost, sad face. So let's go ahead and run through a few rounds of this just to see if it works as expected. So we're going to go ahead and play 3 rounds. We'll choose rock. So if you choose rock and the computer chooses paper, you're going to lose that round. If you choose paper, we lost again because the computer chose scissors. And we'll just choose paper again. And then that round, it looks like we tied. And now this is the final thing that gets printed, you lost. So it looks like the you lost and the you tied are kind of like compressed together. So what I'm going to do is down here, I'm just going to put in like a little graphics thing. So I'm going to, you'll see what I'm doing in 1 sec. And then maybe at the end, I'll just say, thanks for playing. I'll just play 1 round here. I'll choose rock. And so that round, I chose rock, the computer chose paper, and I lost because I am terrible at this game. And then game over, I lost, and thanks for playing. I could probably get rid of that there. Yes, let me respond to a couple of the comments. Um, okay, so if you want to do any sort of machine learning, there are a lot of open source libraries to do machine learning with Python. Let me just pull one up real quick, and I can just kind of show you. So for the uh, so for the person that asked for the machine learning source code, I would follow that tutorial. That should get you up and running. Actually, doing the coding for machine learning is really not that hard. I've done it for work. I actually decided not to do it anymore because I actually found it pretty boring. The underlying mathematics of machine learning is pretty dense, but the actual application of it is pretty easy. The hardest part with machine learning is choosing the right data set. But that should get you up and running. And then, do you need to define the function before you call it? You actually don't. So you can actually put the function after the main method. I just try to always put the main method last, but that's not actually needed. Like I could put that get player and computer choice function below main, and it would work fine. And yeah, like this is just my way of formatting it. But I would also recommend looking at other Python code, like other professional Python code on GitHub, and just see like how other people choose to structure their programs. This is just something that I personally like. So I'm going to go ahead and define another function actually, where I take all this and put it in a function. So I'm going to write a function called def determine. Maybe I'll put it under here. Def determine results, and I'll put in player wins here as a parameter, and I'll put in computer wins here. So what that allows us to do is we can just pass the number of player wins, and we can pass the number of computer wins to determine results, and we can just take all this code and put it in that function so that it's not clogging up our main method. So we would just, yeah, that's it. So then we would just call determine results down here. Just pass in player wins and computer wins. So at this point, we actually have a pretty functional program that allows you to play multiple rounds. Now, and I'll go ahead and just update what I have in the code share. So right now, we don't allow the user to play again, but there's actually a super easy way to do that. And this is really kind of this is one of the best parts of having a main function is that we could call it again. So we can say something like user play again gets input, would you like to play again? And then if user play again is equal to yes, we just call the main method again. Else we print thanks for playing, bye-bye. And then we'll just put in here, say yes to play again. And we'll do the same thing we always do, where we just we strip the input string and then we convert it to lowercase. So yeah, we have a pretty functional program. So we have so let's say how many rounds would you like to play? We have 5 rounds. Choose rock. Uh-oh, we did something wrong here. I actually don't know what happened here. Oh, yeah. So This is actually one of the reasons why it's good to just kind of consolidate your code as much as possible, because I did a thing where I put determined results, which is supposed to be called after all of the rounds are completed. I actually call it at the end of each round. So that's easily fixed by just backspacing there so that determined results is no longer inside of that for loop. But yeah, that's a really easy error to make because Python is white space sensitive. White space is as much a part of the code in Python as anything you type. So if you use something like Java or JavaScript, the white space is almost meaningless. Like you could write a Java program that would usually be like 1,000 lines in one line if you wanted to. That just wouldn't be readable. The white space is pretty immaterial to the actual execution and flow of the code. In Python, it's actually extremely important to be able to make sure your white space is where it should be. And yeah, so for user inputs, Python is absolutely case sensitive, which is actually why I always end up putting .strip.lower at the end. .strip removes all the white space at the end of your inputs, so just in case you put an extra space or something like that. And then .lower converts all of the characters to lowercase the best it can. So let's go ahead and try that again. So we'll play 3 rounds. We'll say rock. We tied. We lost. And we win. So we have a win, a loss, and a tie. So overall, we tied. And then we can type yes if we want to play again, in which case it's just going to go and ask, how many rounds would you like to play? Say 1, enter rock. I win because I'm awesome, and I don't want to play again. So then we're done. Thanks for playing. Bye bye. So this is looking pretty decent so far. Now, the things that I want, but there are some issues with this program. So something I would like you to do, and I'm going to give you a few minutes to try this yourself. I would like you to copy the code that is on. Actually, let me do it like this. I'm going to make a. I'll put this on Pastebin so that it's not modifiable. So go here and you can copy all the source code that I just made. You can totally put this in your own Python environment and run this. You can use Repellent, you can use PyCharm, whatever is going to be the most useful to you. And you have a job to do, and I would like you, and by the way, this is the most fun thing you can do in software engineering. Sometimes I think I should have done quality assurance instead, is break this program. So basically, I want you to try doing this yourself. Take like maybe, I'll say 10 minutes, actually. I actually want people to really try and do this. I want you to break this program the best you can. I want you to make it not work. I want you to try different user inputs. I want you to confuse it. I want you to, you are going to be so you are going to play hacker right now, and in this hacker LARP, I want you to just try and make this program not work. And once we do that, once we go through that quality assurance phase, we'll actually try to go in and fix each of those issues. If you find an issue, or you have a test case that did not work for you, or like a way you could break it, please let the chat know, and then we can go through each of them individually. I actually already have a few things that I know are broken with this program that would make it not work. So give that a shot, and I'm going to go ahead and let you have that time. Let me just put on a timer here. And then I will also go ahead and put on some chill beats to break my program too. Okay, so let's see if we can figure out a way to essentially just make this program not work, and then think about what we can do to fix it. So one of the easiest ways to break a program generally is to do something like just give it garbage user input. Um, so that's actually kind of like one of the easiest ways to engage in any sort of hacking. So one of the things that you always have to do is sanitize the user input, because if you don't sanitize the user input, bad things can happen, especially if, for example, the user input is used to query a database. Then you can actually do something called like an SQL injection, which would allow you to modify a database. So that's not relevant here because obviously we're not working with any databases, no SQL or anything like that. But so let's say the console asks, how many rounds would you like to play? And we're just going to say at, we're just going to basically give it a bunch of garbage input, and we're going to get this. So it says invalid literal for int with base 10. And what that means is that's not an integer. Clearly, this is not an integer um, in base 10. Base 10 number requires digits from 0 through 9, and this is just a bunch of garbage. So what we want to make sure we do is actually determine if this is valid input. And especially we want to make sure that we take this string, and we don't want this string, we need this string to be something that can be converted into an int. So what we can do is that there are a couple of ways to handle this. So first I'm just going to separate these out a little bit. So I'm going to say rounds to play string is this. Input how many rounds to play. And then we'll change it so that we're just converting this string into an integer. And we'll see if there's something we can do with that. So one of the things we can do is just we can look through the string, and we can make sure that each character is actually a digit. So we could do something like this, where we could say for char in rounds to play string. So essentially, we would just be looping through that string. If char not in, and then we could just, kind of have a list of all the valid numbers here. We're not going to do this, but I'm just showing you like this would be a possible way to solve this. So now we can do something like this. So now if I enter that garbage input, it's just going to say invalid user input, and it's just going to restart the program. So now we would be unable to do anything silly. Yep. So in this case, actually, I just found another issue just by spamming the enter button. Now or maybe we'll keep this. We'll even make a method. We'll say def determine if valid user input, something like that. Determine if valid rounds user input specifically. So we might do some input validation somewhere else. So we pass in the rounds to play, or I'll just say a string to parse. And then we can say something like this. So for char in string to parse, if char not in, so essentially we're looping through each character of the string, and we're going to check to see if that character is in this list of all these numbers. In fact, we can even make this a tuple, because we don't need to modify that. We would print invalid user input, and then we'll return true if the string is valid. And if at any point we can just return false if the string is not valid user input. So if determine if valid rounds user input, if not. So essentially what that means is we're going to get the user input, and if we determine that it is not actually a valid string that we can parse into an integer, we're just going to recall the main method. And something else I actually noticed was another way, something else that we can put in here is if we put in a blank, so if we just press enter and we pass something blank, uh, that's actually going to be invalid because we can't even really loop through it. So in that case, we can just say if string to parse is equal to a blank string, we just return false. So run, press enter, and we can even print, do the same thing. Print invalid user input. Input was blank. And then down here, we can put input was not a valid base 10 number. And if you've ever programmed before and you're familiar with exceptions, I'm kind of actively avoiding using exceptions right now because I'm going to cover those next time. But for now, I just kind of want to show you what some input validation would look like. So it looks like we're probably okay here now. So we can say, how many rounds would you like to play? Invalid user input. Input was blank. We just put in some garbage. Invalid user input. Input was not a valid base 10 number, and it asks again. So that looks pretty good. But now when we get down here, when it says, please enter your choice, rock, paper, or scissors, let's try to put in some garbage again. Well, that's not what I expected. So when I put in garbage, the computer still chose something, and then it just says, please enter your choice. Oh, and that does make sense, because essentially what happens is we put in our user input, we put in this garbage, the if statement, the computer will just, Python will just do exactly what we tell it to do. And it actually did exactly what we told it to do. It took the user input, and then it looked through and just said, well, does any of this work? Player choice did not equal computer choice because the computer cannot choose this garbage. And there's nothing in our, there's nothing in our statement that allows us to actually go back, or I'm sorry, not to go back, but to check if this is garbage. But what we can do is we can put an else statement down here, and this will essentially just catch and see if the user input that we entered was invalid. So this is always just, so whenever we get to the else statement, it just means that whatever we did was invalid. So in this case, we can just say print input was invalid, try inputting again. Or we could actually do this even before any of the decisions are made. So I'm actually going to do it up here. I'm going to say if player choice not in, and then remember we have this constant up here, possible choices. So we're going to say if player choice not in possible choices, then we actually want to restart the round. And there's a way that we can restart the round, but we don't want the current round to increment in the same way. So what we can do is we can say, we can subtract from the current round. So essentially, we want to restart the loop. But as far as I know, there's no way to just restart the loop and keep the incrementing variable the same. In this case, the incrementing variable is current round. So we'll just subtract 1 from current round, and we can use continue. So continue is a very specific keyword in Python, which means go back and restart the loop. So this will allow us to validate the player choice. So we'll say we'll play 1 round, we enter in some garbage, and not what I expected. So for some reason, it didn't actually take the player choice and make it, it didn't actually check this. Let me debug this for 1 second. So maybe continue is not actually the word I'm looking for. Let me see. Well, we can do this another way. So we'll still keep this if player choice, not impossible choices. Um, yeah, so we'll do it like this. We can just say print invalid input for choice. Please pick either rock, paper, or scissors. And then what we can do is we can say something like, well, actually, we can just call this method again. And what I'm actually going to do is make this a while loop. So what's going to happen is first we'll allow the user to try to put in their choice. And we're going to say while player choice, not impossible choices. So we're going to keep asking the user for a valid input until they actually put something in that we know is going to work. So in that case, we're going to say something. So let's see if this works. Play one round. We're going to put in some garbage. And so it still tries, it still says, oh, no. So that does make sense because since we're calling this method, the computer chose paper part is actually part of this method up here. So I think I'm actually going to take this print statement and just put it after the input and the input validation. So that way we're not going to see that printing out. So we'll just put that there. So let's try again. So we'll play one round, we'll enter rock, and that's not actually what we were trying to do. Let me put in some garbage. So invalid user input. Input was not a valid base 10 number. We'll play one round. We'll enter some garbage down here. Invalid input for choice. Please pick either rock, paper, or scissors. Put in some more garbage, put in rock, and now it works. So now it looks like this is a pretty functional program. So let me go ahead and just put this on the paste bin, or I will make a paste bin for everybody to use so that you can copy and take a look. So I'll call this Python RPS final. Yeah, so if you want to play around with this code and just see, what you can do with it, maybe you can make it better. You could almost definitely make this better. I know that I'm kind of just coding off the top of my head here without really any planning. So that means that there's almost definitely something I can be doing differently. But at the moment, this is actually a functional program. So we're going to go ahead and just keep that as is. So see if you can build something similar to this. See if you can follow along. Before I talk about anything else, does anybody have any questions about this one? I just kind of wanted to give everybody the opportunity to see kind of like how we go through, how we can just build something and how we can go through the planning process, even though the planning was pretty sparse compared to the planning that I'll usually do. A lot of times when I'm starting projects, I'll actually have to write. A lot of times when I'm building projects, especially for work, I actually have to go through a design process, which involves like creating like a 6-page document that people can look at so that they get an idea of how I'm going to be designing and like what choices I'm going to be making. So yeah, it looks like, so it doesn't look like there are any questions about that. So that's totally fine. So go ahead and just copy the source code and try playing with it in your coding environment. See if you can do anything different with it. Um, and then, so for for homework, just for Wednesday, I would like you to get a Linux terminal set up on your machine. There are a lot of different ways to do that. You can use Cygwin. You can. It looks like there's a Bash shell for Windows 10, which would work just fine. And also download Git for your computer, so you'll be downloading the Git terminal. And then on Wednesday, I plan on actually going through the Git setup process so that you can set up your own GitHub repository if you haven't already done that, so that you can start putting up your coding projects. And a lot of times when you're applying for jobs in the software industry, they actually look at your GitHub, and you will put your GitHub on your resume. And you do that just so that they can take a look and see like if you've actually built things before. Um, so yeah, does anybody have any questions about any of that? Okay, so it looks like everybody's good. So get that done before Wednesday, because that's, if you don't get that done before Wednesday, it's going to be hard to follow along with what I'm going to be doing. And then we'll get a GitHub repo set up, and we can actually start making contributions to it. I'll teach you a little bit about the command line, and how to think about the command line and how that represents your internal computing system. If anybody has any questions so far, otherwise, like just things they don't really understand in Python, maybe I did something in the code today that wasn't quite clear, um, then just let me know. You can send me a message, and I can just help you out one on one. So hopefully that was helpful, just to see like kind of going through like building a full program. And if not, I won't do that again, and I'll just go back to a more typical lecture format, and just do that from now on. But yeah, try doing that. Do some coding bat just to kind of keep your Python syntax fundamentals fresh, and have a great rest of your day.